Good evening to everyone, and thank you for giving me this opportunity in this COVID platform to spearhead some knowledge sharing. And so, as Ifsa has already mentioned, so let me just give a brief of what am I engaged with Infosys right now. So currently, I'm managing the America ERP portfolio of Microsoft unit, which means we are into the implementation of Microsoft's features around enterprise resource planning for clients from different verticals, mainly from USA and Europe region. And my overall expertise summarizes to program management, product management themes like product engineering, product development, product implementation, driving automations in the IT ops areas, helping the customers achieve extreme automations. Um, so now we will switch the context to the theme of this session before moving forward to the AI ML in the manufacturing area. Let me give tell you a little story about my last 10 years of
Ma'am,
experience with
excuse me, ma'am.
yeah, it's a
Ma'am, can you be little bit louder? Actually, participants are
okay.
saying voice is very low.
Okay, let me check the volumes at my end.
Yes, ma'am.
Is
Yes.
it better now?
Mm,
Is it better now?
yes, ma'am. You can start.
Okay. Okay, so before moving forward, I want to tell a little bit about my product, a product which I have worked on since last 10 plus years, which is called Polycloud Automation Platform, with which I spent more than a decade of my career, and it is very close to my heart. And I can't stop mentioning about this product whenever I go to any such big forums. So Infosys holds an IP for this product, and it helps in automation of cloud infrastructure, orchestration, provisioning of cloud virtual machines with variant flavors like platform as a service, infrastructure as a service, database as a service, etc. It also capable of end-to-end incident management workflow. It has inbuilt workflows for automating incident resolution, service request fulfillment with approval workflows, and also has great features with AI ML capabilities. Since it involves automations around the IT ops tracks like compute, database, network, security, and observability areas, it can be implemented by any organizations across various industries planning for or has already started their IT ops modernization journey. So, with this, let me take you through our topic today, the role of artificial intelligence and machine learning in automation, especially how they are reshaping industries like manufacturing. Today, we'll explore not just what AI is, but how it works, where it is headed, and how you can harness the power to drive innovation and efficiency. Let me start sharing my screen. It's a let me know when it is visible.
Sorry, yes, it's visual.
Okay. Okay, so here's the quick overview of what we'll cover today. We'll start with the basics of AI, then dive into how it works, the different types, and how machine learning fits in. From there, we'll explore real world applications, benefits, risks, and how AI is impacting business and daily life. We'll wrap up with the future trends and strategic recommendations. So, yeah, before moving, let me just clarify from the beginning, I'm not an expert into these AI technologies, but what I know is from my experience on the ground, the applicability of all these technology. So that is enough for the industry leaders to take forward their journey with AI implementation in their respective organizations or industries. Okay, so this slide talks about the entire arena of AI. So artificial intelligence is a broad field concerned with creating systems that perform tasks which would normally require human intelligence. So the difference between human brain and machine lies in the capacity to store and process data. Where there is a limitation of human brain to recall long-term memories, processing huge amount of data, and the data which is very complex, and in the like at the moment drive the meaningful insight from it, right? But the machines are at an advantage. They can supersede human being to store huge amount of data set, process it, retrieve it in a fraction of seconds whenever required. That is where nowadays we have everything artificial. There is artificial flavor, artificial color. Similarly,
Excuse me,
so
ma'am, if you can increase your voice a bit, please, because
okay,
that is
sure,
slow actually.
sure, not sure. It is. Okay, let me try to be as closer as the system, and let me know. I am not very sure why this volume is very low today. Maybe network bandwidth issue, but let me know. Interrupt me whenever I am feeble. Okay, so that's where I was telling about the artificial intelligence. Some of the intelligence human beings actually came up with this concept of artificial intelligence with lot of research. But just to inform, this concept of AI comes long ago when the computers are actually invented. So the core area of artificial intelligence is model and automate cognitive tasks such as perception, reasoning, planning, and decision making with the machinery techniques. So some of the real world uses are like autonomous agents, recommendation systems, diagnostic tools, industrial automation, and smart assistants. So next to artificial intelligence comes machine learning, which is a more specialized version. Machine learning is nothing but a subset of AI that builds systems with which can learn patterns from the data we were trained with to make predictions or decisions without explicit rules. So the core idea is using statistical models to map inputs to outputs and improve performance with more and more amount of data. The more data we feed to the model, the more accurate the prediction. The key paradigms where we use machine learning are supervised learning, classification, regression, then unsupervised learning like clustering, dimensionality reduction, etc. And also the reinforcement learning, like the way robots operate. So the real world uses are fraud detection, demand forecasting, personalization, animal detection, and predictive maintenance. Then comes the neural networks. Neural networks are parameterized function approximators inspired by biological neurons of human brain. They are the building blocks for many modern ML systems. And some of the real world uses we can see is the feature extraction, time series modeling, image recognition, speech recognition. Then comes the deep learning. Deep learning is the practice of training large and multi-layer neural networks that learn hierarchical feature representations from the data. The real-world uses are state-of-the-art system in vision, language, speech, and multidimensional tasks. Then the most recent happening one is the generative AI, which focuses on the models that can create new content, text, image, audio, or video. Often we cannot distinguish it from the human created material. So the real world users are mostly the content creation, image, music, any kind of contents like story, then summarization, conversational agents. We use chatbots these days for in every sphere. So code generation, the Copilot, Microsoft Copilot also, and there are other variants of Copilot code generation tools nowadays. Then certain other creative tools also use this generative AI. So then let's quickly move to our manufacturing area. Why do we need AI/ML in manufacturing? Um, Already we have cutting edge machines performing most of the labor intensive tasks, right, to ease our life. So why do we still need AI/ML? So to answer that, manufacturing is facing a perfect storm nowadays, right? Rising complexity, global competition, and the need for speed and precision is the call for the hour. So we can see there are a lot of examples of emerging product complexity like smart homes and appliances, devices like smart thermostats, refrigerators, and home control systems. Then wearable health tech, right? The smartwatches and the fitness trackers we wear, autonomous connected vehicles. So Tesla has already started experimenting on the autonomous vehicles. Then there are many other mass customized goods which also bring onto the or add to the complexity of this manufacturing industry. Similarly, in the business area, industrial IoT and smart manufacturing, then smart supply chain management, AI-powered diagnostic tools for healthcare, then complex software systems for the cloud platforms. So these are all the examples of such complex products which we need nowadays, and it makes manufacturing more difficult. In order to help that, for the higher efficiency and gain the competitive edge, we have to adopt AI/ML in this industry so that we can do the just to this demand. Then moving on, there is driving the quality and innovation also in this industry 4.0. That is also like only if we adopt AI and ML, we can spearhead this quality and innovation in the industry 4.0. And also like process optimization and automation overall summarizes the demand for AI/ML. Okay, then we can see some of the use cases in the manufacturing area which transforms manufacturing with the help of AI and ML. AI and ML are transforming industries in the ways that are both surprising and profound, from diagnosing diseases to composing music. So there are many fascinating facts that showcase their versatility impact, right? So AI, for example, some one healthcare revolution nowadays. Machine learning models can detect diseases like cancer, diabetic retinopathy, right? And it can help in the complex surgeries. So just by using giving some instructions, doctors miles apart, they can perform complex surgeries using the AIML technique. Similarly, nowadays smart cities are driven by AI, like smart cities which are enabled and adopt AI. They can do the urban planning and like managing traffic, reduce energy consumption, improve public safety. So there are many such examples like Singapore and Dubai, which are the fast runners in this area. Similarly, in the entertainment area, Netflix, Spotify, YouTube, these are the examples where like they adopt AI to judge the human tendency, and they offer the suitable contents, and that is how they are making millions of business. Similarly, there are other areas like environmental sustainability, AI market explosion, AI-driven human games, then some emotion recognition systems like the lie detectors, AI-generated art and music. So these are all the examples of the latest adoption of AI and driving excellence in this area. Then let's these are the some key areas where AI is making real impact in the manufacturing. The top these are some, but there are many, but I have tried to summarize in these 6 areas. First one is the predictive maintenance. AI analyzes sensor data to detect equipment anomalies, then predict failures before breakdowns occur, reduces downtime and maintenance cost. One of the example is Siemens uses ML to predict gas turbine maintenance schedules. So next one is quality control and inspection, where computer vision systems inspect parts in real time. Our Tesla is the burning example of that. ML models detect defects invisible to human eye. Why? Because of the precision of the image recognition system nowadays. Then ensures consistent product quality. One example again is BMW, which uses AI for this kind of inspection and product quality improvement. Then supply chain optimizations, we have lot of examples. AI forecast demand and adjust production schedules. ML optimizes inventory levels and logistics, reduces waste, ensures timely delivery. I'll come to some of the real world case studies, during COVID, how Pfizer used AI/ML to improve their supply chain management. Then there is demand forecasting also, where a process of predicting future customer demand for a product or service using historical data, market trends and analytics is being leveraged by many companies. Then historical sales data, analyzing past trends to anticipate future demand. Then market analysis, considering economic indicators, competitor activity, consumer behavior. So like seasonality and trends, adjusting the forecast based on the seasonal patterns or emerging trends. We often see during the Dasara time, there are a lot of offers and all, they start flooding to our system. So all those are driven by the AI driven rules put forward by such consumer companies. Then most important one is the process optimization and automation. So involves improving business process to make them more efficient, cost effective and scalable. often through automation technologies only. So the workflow analysis can help them identify bottlenecks and inefficiencies. So the Lean and Sigma technologies, applying methodologies to reduce waste and improve quality. And the automation tools are using we use the softwares like RPA, robotic process automation, and the one example automation platform I gave from the beginning, right? So those kind of automation platforms are spearheading the automation implementation in day-to-day operation, leading to huge manual effort saving, and leading to the cost savings also. Real-time monitoring. So yeah, the leveraging the IoT and analytics platforms, right? Systems performance can be tracked, and the adjustments can be made dynamically. Last but not the least, the robotics and computer vision. We know the impact of robotics nowadays, the adoption of robotics transforming industries by enabling machines to perceive and interact with their environment. They can collaborate with the human beings and work as cobots. Then industrial robots used in manufacturing for tasks like welding, assembly, packaging, all those are the real life examples. I will dive deep into all these points later. Yeah, so these are some of the real world case studies I was talking about in the predictive maintenance area. Companies like PepsiCo, they used AI driven predictive maintenance using sensor data and forecast equipment features. The impact being reduced unplanned downtimes and increased production capacity by 4,000 hours. Around the quality control and inspection, yeah, I already mentioned BMW. It has installed AI powered vision systems for real time defect detection and around the assembly lines, and the impact is improved consistency and reduced human error in the quality assurance. Then in the supply chain optimization, Pfizer, during the COVID, like when there was a rise in COVID cases, it used the AI/ML techniques to predict demand fluctuations across the regions based on the infection rates and vaccination trends. Then the impact was improved delivery precision, reduced spoilage and waste, which also help them with accelerated decision making. Then demand forecasting. Now, our Walmart is the best example for that, where AI models analyze historical sales and seasonal trends to predict future demand. The impact being better inventory planning and reduced operational cost. And the robotics and cobots case study comes from soft robotics with NVIDIA, where the use case is AI-enabled robots trained with synthetic data to pick up irregular objects like chicken wings. And impact was enabled automation of previously manual tasks in food processing. Then generative design. Uh, the company is Airbus, which used use cases like AI simulating thousands of design iterations for aircraft design parts. And the impact was reduced aerodynamics prediction time from 1 hour to 30 milliseconds, enabling rapid innovation. Then we'll see how intelligent robotics is transforming the manufacturing area. So the first point tells about manufacturing, how AI-powered robots perform precision tasks like welding, assembly, conducts real-time quality inspection using vision systems, handle predictive maintenance by monitoring equipment health, then adapt to changing production lines with minimal reprogramming. Then moving to the robots in logistics, like again, similar kind of tasks, automate picking, packing, sorting of in the warehouses, use AI to optimize routes and reduce delivery times, collaborate with humans in shared workspaces, improving safety and efficiency. Then applications in healthcare, assist in surgery with high precision, deliver medications and supplies in hospitals, support elderly care with mobility and monitoring. AI enables these robots to respond to patient needs, the recognition of human emotions. That is the AI ML part induced. Like earlier, robots were already operating, doing some manual tasks, but with added flavor of these AI ML technologies, make it equivalent to human support, right? Leading to the patient, catering to the patient needs and environmental changes. Then some key trends which is emerging in future are the humanoid robots like Tesla bot, designed for human-like interaction, collaborative robots or cobots, which are designed to work safely alongside humans. So they can take cue from the human uh, actions, and they can also take orders from the human beings and execute flawlessly. Similarly, sorry, just a second. Okay, so there are some challenges and ethical considerations because, no technology comes without challenges, right? There are a lot of hurdles, challenges we have to overcome in order to make this relevant to the working on the ground system. So ensuring safety in human robots interaction, that was the key challenge, which we have almost overcome now. Oh, it is still evolving, but we can see, like, I have one example how Tesla robot is almost, they have nearly achieved perfection. So addressing the
त्या पण असं असा इकडून तिकडून खवरा ना नाही त्याला बघला का जाऊ बाय बरं होईल तर पण ते नाही ना तुमचा पेजच बंद झाले ना
sorry,
आता
can,
पनीला पहिले आहेत ना ठेवली ती मामींची घर आहे आता एवढं सिंपल म्हणजे भाऊजी कोण असता ना घर
can you please mute everyone?
होती तर बायको ती आता तणावली
तिला पिंपलवर आहे वडावर आहे
ना तो नाही काही रे बाबा काही आणलं नाही ती आणायला काय माझ्या घरी काय मागवले
Vinod, can you please mute?
ती गोळी नव्हत्या त्या गोळ्या होत्या
त्या गोळ्या आणल्या का? वाटलाच ना
ओमेगा 3 किशोर
I'm sorry, I'm not able to see from whom noise is coming. Please mute yourselves. Yeah.
कलर कुठला होता
ब्लॅक कलर होता
Okay. So
ইন্সপেক্টর সে শান্তিনিকেতনে ফ্ল্যাট কিনেছে তার গৃহপ্রবেশ টাইপের আর কি হ্যাঁ ওই ও দেখতে যাবে আমিও দেখতে আমাদের বলে যে তোমরা এসো
can you please check?
আমি বললাম ঠিক আছে এখান থেকে
who
1.5
is,
ঘন্টা জার্নি কি আছে চলে যাবো আর আমার বাড়ি থেকে তো 1.5 ঘন্টা লাগে ম্যাক্সিমাম 1.5 ঘন্টা
Dr. Arghya Majumdar
1.5
and
ঘন্টা হলে
Vinod
চলে
Bhil
যাবো
from there actually noise is
তাই প্ল্যান করেছি। আর রবিবারটা তুই সকালে সকালে আমরা রবিবারটা পুরো খালি রেখেছি।
Okay, guys, I think I can begin this. I have one sample,
কটার
a
সময়?
nice video from Tesla, so maybe we can get started.
হ্যাঁ ঠিক আছে, 10:30 বেরোবি, ফিরতে ফিরতে বিকেলে বসবো 3টের সময় বা 4টের সময় বসবো। 4টে থেকে 6টা 7টা কাজ করলেই হয়ে যাবে, মিটে যাবে। 4টে কি 5টা করে রাখ,
In
তোর
the
যখন
meantime,
সুবিধা, আমি খালি
you
আছি।
can watch this video and enjoy.
কোনটা? হ্যাঁ হ্যাঁ হ্যাঁ, ও নোটে লিখেছে, হ্যাঁ ঠিক আছে। হ্যাঁ ওটার আমি আর দেখিনি, আজকে আরো অনেক কাজ ছিল। পরপর একটা পেপার সাবমিট করলাম, অনেক কাজ করি সকাল থেকে, বুঝলিস? হ্যাঁ, ছেলেপিলে ভালো, ছেলেপিলে ভালো।
Stay with the Times of India for news breaks, analysis, interviews, and events.
Okay, so hope you could draw the gist of it, like how the modern is robots are driving like almost near to achieve the excellence and performing all sorts of human actions. So now we can say definitely AI-powered robotics is not just the future, so it's the present. We have almost achieved it. As these technologies mature, they will become integral part of our day-to-day life and the industry. They can contribute immensely to the industry, leading to improved productivity and quality. The key is to the responsibility lies with the adopter, like to adopt the responsibility, innovate boldly, and prepare our workforce for collaboration with intelligent mechanisms. So now then let's move on. Here we have tried to summarize some of the benefits of AI ML in manufacturing industry. So it is, though it is difficult to sum up all the benefits of AI ML brings onto the table. So these are a few of them. Supply chain optimizations, AI models forecast demand, manage inventory, and streamline logistics, resulting in a linear operations and better responsiveness to market changes. Then increased productivity, AI-driven automation and intelligent scheduling can boost operational efficiency by up to 3 times, enabling faster production cycles and reduced manual intervention. Then enhance quality control. Machine learning and computer vision systems detect defects with near perfect accuracy, leading to 99% defect reduction and improved product consistency. Enhanced security posture. So security is the key aspect of in the every all the spheres of industry, not only manufacturing but mostly the computer. Uh, the cloud operations and all such areas. Then amplified end user satisfactions also, like the moment we improve the quality, it will lead to the end user satisfaction. Cost savings. The predictive maintenance helps avoid unexpected equipment failures, saving millions of repair cost and also downtime cost, as seen with Reynolds, which was equivalent to euro 270 million savings in last year. Process automation, repetitive and time consuming tasks are automated, freeing up human resources for strategic and creative work. Then it drives innovation and acceleration. So AI enables rapid prototyping, smarter product design, and data-driven R&D, helping manufacturers stay ahead of the curve. Energy efficiency. AI optimizes energy uses across facilities, reducing consumption by up to 30%. Companies like Georgia Pacific have saved hundreds of millions using this technology. Then here are some of the emerging AI trends shaping 2026. Looking ahead, we always try to achieve more, whatever we have achieved so far in this area. Generative AI goes mainstream. AI is now capable of creating text, images, music, and video integrated into everyday tools. There is no tool nowadays we can imagine without AI, right? This is transforming design, healthcare planning, product development workflows, etc. Embedded in design is the example of like where we are using the AI ML technologies to come up with cutting edge product designs. Then second one being the agentic AI or the autonomous AI agents. These are the agents who can execute tasks across applications without human intervention. They are revolutionizing schedules, workflow automation, and decision making processes. Then multimodal AI interaction, which is about AI models which can now process text, voice, images, and video simultaneously. This enables richer real-time analysis in classrooms, video calls, and dashboards. Now, most of the tools can generate meeting minutes and send a summary. Also can highlight the action items and next steps. So, which is helping lot like to the managers, saving lot of time and contributing towards more strategical level in their respective areas. Then AI personalized education and upskilling. Yes, so AI has also revolutionized the educational sector. Yeah, the adaptive AI tutors tailor learning paths based on individual needs, preferences, and labor market trends. This helps bridge skill gaps and prepare the workforce for future roles. Predictive and preventive AI. AI system can forecast failures, fraud, disease onset before they occur. So this will help immensely. This is already helping us in a lot of ways we have already observed. We have so many samples or examples available in the industry. These capabilities are being embedded in logistics, finance, healthcare, every aspect of industry. Last but not the least, the responsible and ethical AI. As AI adoption grows, so does the focus on transparency, fairness, and compliance. Ethical deployment is becoming a key priority for organizations worldwide. Then moving on, the strategic recommendations. AI adoption isn't just about deploying algorithms, right? So it's about aligning technologies with business goals. A strategic approach ensures that AI initiatives are scalable, ethical, and deliver measurable value. So without strategy, AI risks becoming a fragmented and underutilized area. To succeed with this, the AI adoption, we should follow uh, some of these approaches we have tried to outline. Yes, there are many other aspects if we uh, dive deeper into the micro aspects, but these are at a high level. Before getting started, evaluate the current capabilities, understand your data maturity, infrastructure, and workforce skills. So then we have to set clear goals, like our objectives in the business, what we want to achieve. Define what success looks like for us, to us, right? We cannot just hit to the blind spot, right? So we have to set some goals around the cost savings, some of the innovations areas, and customer experience. Then we can identify the high impact areas, like focus on domains where AI can deliver quick wins and long-term values. Then to start with, we can invest in the high ROI use cases, where the examples being predictive maintenance, quality control, whereby through predictive maintenance we can draw immense values. We can do lot of cost savings by avoiding errors or downtimes of the systems. The next one is the invest in data governance and cyber security. Data quality is always critical. AI is only as good as the data it learns from. So the quality of the data, the better results it can deliver. So we can establish governance frameworks, define ownership, access controls, and compliance protocols in order to achieve this. Then secure infrastructure also is coming under the cyber security, where we have to protect sensitive data models and breaches and misuse. We have seen multiple examples of data breaches, data theft, because of this security weak systems. Then moving on, the next one is collaborate with the tech partners and startups. So what we can do is leverage the external expertise. There are multiple new startups blooming nowadays, right? Tech partners bring specialized tools and experience we can leverage by collaborating with them. Then we can co-innovate with startups. Agile startups can accelerate experimentation and deployment, then build ecosystems of collaboration and fostering innovation and reducing the time to value, right? We can quickly achieve our target by collaborating with such tech partners. Next one is we should focus on upskilling and empowering our workplace, right? AI literacy is must for all nowadays. Train employees across functions to understand AI's role and impact the usage, equip the technical teams with tools for model development and deployment, and also using the existing models already available, AI ML based tools, and also help the change management area address fears and resistance with transparent communication and support. By looking at the change management area, instead of people fearing AI ML that they will eat our AI is eating our job, right? They can easily adopt the AI to leverage its power and drive excellence in their respective tasks. Then comes the prioritization of responsible and ethical AI, which is of most importance nowadays. Fairness and transparency ensures models are explainable and free from bias. So lot of time we have seen, we start using a model and uh, the output or result given by the model is not always correct. So there lies the issue with this fairness and transparency. Sometimes we don't feed the model with accurate data, which lead to, I mean, some wrong outputs like hallucination and all such. Then the compliance and accountability also matters. Align with regulations and ethical standards. There are set of Gen AI guidelines, ethical AI guidelines defined by every organization whoever wants to adopt these, and we have to follow these rules and regulations in order to adopt the AI technologies. Then human oversight, maintain control over critical decisions and outcomes. Finally, measure, monitor and iterate. So what we cannot rest in peace unless, once we adopt the AI technologies, right? We need to define the KPIs to track the performance, the ROI and user adoptions. So unless we track this, we will never be able to get into conclusion whether it has actually driven results or the key goals or not, right? Then after defining and monitoring the KPIs, what we need to do is try for continuous improvement using the feedback loops, refine the model and processes. We have to keep on improving the model. There are all such models which are capable of self-improving, self-learning using the feedback loops. We should leverage that to enhance our AI capabilities. Then scale responsibility, expand AI use based on proven success and organizational readiness. So that is about the strategic recommendations. So finally, I think I have reached to the end. So my conclusion will be AI adoption is a journey, not a one-time project, right? And by following these strategic recommendations, organizations can build resilient, innovative, and future-ready operations. And the time to act is now. Start small, think big, and scale smart. And keep our uh, eyes and ears, all our senses open to the cutting edge latest advancement in this area. AI will definitely continue to evolve. There is still potential is not yet achieved, I would say. So becoming more intuitive, autonomous, and embedded in our daily lives. AI can achieve to excellence, and what we haven't even thought of, from our personalized healthcare to intelligent cities, to the impact will be profound. But with this power comes the responsibility as well, like ethical deployment and human oversight will be critical to ensure AI serves society positively. So thank you all for joining this session. Ipsita, I'll hand it over to you, and the floor is now open to for any question answers.
Thank you, ma'am, for the talk. So I request the participant if they have any questions, you can ask. You can unmute and ask. No problem.
Hope the content was, in such a shape that people could have learned something, right? It was not.
Yes, ma'am. Yes, ma'am. No problem. Ma'am, there is a question in the chat box. How will AI improve sustainability in factories?
Sorry, your voice is breaking. Let me look at the chat.
Yeah.
Okay, yeah. So as I have already touched upon this point, right? So AI can contribute to the sustainability by optimizing the resource uses, right? Like energy, even in the agriculture sector, in the transportation, and the improving by doing the close monitoring of the environmental and predictive, doing the predictive anomalies and all such, right? So it can help us achieve the excellence by the minimal and critical usage of the resources, leading to the helping to our sustainability goal.
Machine learning questions. So there is another question, ma'am. How does generative AI fundamentally change the traditional engineering and R&D workflow, and what are its current limitation in mass production environments?
Yeah, so at present, generative AI is so R&D, definitely it is already contributing, because the generative AI fundamental comes from huge content. So it can accumulate content data from every sphere. So lot of like areas, social media, the contents. One example is Wikipedia. You must be knowing, right? Which is having lot of contents. Similar to Wikipedia, there are many other dictionaries, some of the systems having information. It can collect data from every sphere, and this is how it will be able to help us with R&D. In the R&D area, we can uh, ask for the prompt engineering nowadays, right, plays a key role in this R&D area. So the better prompting we can do, the better question we can ask, the better content it will provide. We can help it give us innovative ideas, to summarize some contents, to make presentations in certain areas, to draw insights from huge set of data and all such. These are the examples how generative AI can help us, and is already helping us in the R&D area. And yeah, as I think the second part was how what is the limitation, right? So the limitation being, again, the same reason why it is helpful is the limitation also. It cannot create content on its own, right? So if there is an unknown area or unexplored area, right, so it will definitely start hallucinating. So only when we feed it with data, it will come up with the answers, right? And sometimes it also goes in a biased approach, right? Goes into a biased approach where like the kind of data which is fed into it plays a key role in that, and it can give us wrong output or wrong results. So those are the limitations, key limitations nowadays. And I think everyone, like the key providers of data for these kind of generative AI enabled system like chatbots and all, they are trying to improvise this by giving it different prompts, enabling it with different set of data. Like we can, once the data is fed into the generative model, right? So we can train it with multiple ways. Like if someone answers this, don't give answers like this. So this is one of the example I'm just saying. So similar to that, we can give guidance through prompt engineering to the models in order to make it accurate predictions and come up with accurate response. I hope I could answer some part of that. Yes, there are a lot of other aspects which I'm also still exploring. I'm not an expert in this, but whatever I could answer from my experience so far.
Good evening, ma'am, for the insightful lecture.
Yeah.
I have two questions, ma'am. The first is we come across term like modeling, simulation, optimization, and automation. So how these terms are differ uh, with respect to AI universe? मतलब which level use which kind of model like MML or LLM? My second question is, since you are expert in the field and working from almost 15 years, so what are the challenges that in place of you, why your AI agent cannot deliver this lecture, the lecture you have delivered that? So what are the challenges in that? Can you please?
Yes. So first point was, I think, modeling and simulation, right?
Yes.
Modeling is the creation of a, when we expect a static response, right? When we feed the model with certain data and we ask for some questions. So based on the data processing, the model can come up with definite answers, right? Some of the real world examples will be, let's say a student who wants to like answer a certain question in science. He wants to get to know about the answer of to certain scientific question, right? So to that, I mean, AI, if it will ask to a system, it will just process the data internally. It has already fed, and it can come up with a definite answer to that, right? So these kind of questions will have, those are having definite answer, which may not vary, right? That is called modeling, right? And by providing the right set of data, the model starts working, right? And it can give the desired output. But simulation is like a little bit challenging, because we have to give it like real world different kinds of scenarios it may come across, right? So it is kind of a creativity, right? So like as human being, we can, from our experience, from our knowledge, from our studies so far, we can come up with the creative contents. But uh, they are genuine lacks, they are like and it is different from the modeling in that perspective, where the content is very dynamic based on the questions, based on the situations, it keeps on varying. Okay. And to answer the second part, so yeah, definitely, I mean, let's say if you give give a definite content. You write the content, you prepare the slides and give it to some AI bot. It can definitely deliver it. Like it will read out the points accurately with perfect pronunciation, everything, the wherever with the emotions also. Sometimes nowadays the voice bots are coming with emotions and all. But whenever there is such a question, right, this kind of question answer sessions, it may not like give you the accurate answers. So yeah, that is the challenge, but definitely it can be improved, and this is still evolving. And I think we have already seen, right, some of the organizations, or we can see lot of softwares, tools are available who can deliver the contents, the presentations accurately with the fed data, the static content, right?
Thank you, ma'am.
Mhm.
Okay, so if I give the content to the AI, then it can deliver it. So can it matlab simultaneously generate the quality of your presentation? Matlab, if we not compromise in the quality, so it is currently able to generate that level of quality with the appropriate prompt. I mean the content
Yes,
generation.
yes. The prompt engineering, yes, with proper prompting, right? So it has to, like, even we also use it in our day-to-day scenario, right? Like when we respond to the RFPs, right? So there are some new deals that has come up, and we need to quickly put some contents. So that time, instead of we going ahead and reading hundreds of docs, googling hundreds of sites, and getting the data, right, we can write a proper prompt, and copilot or chatbot can give the accurate answer with the presentation content also. But yes, it's not always accurate, I would say. From my experience, we always need to modify it to our context. The like we might be preparing with some intent, right, with certain themes, and with to achieve some purpose, right, to a certain kind of audience. So keeping all these factors in mind, right, it is not always possible to get the most accurate outputs from the uh, chatbots, or this kind of generative models. So we have to use it, but with awareness, right? And we should be able to judge which content is accurate, which is not, and accordingly we have to modify it. Then only we can use the content. The previous answer to which I said yes, AI can give this presentation, you have to give it each and every line by line content. Then only it can read it out. It can definitely, I mean, it's similar to like we asking Gen AI to create a content or RFP for us. But it will, I mean, it will be most of the time it will be accurate, but sometimes it might give us incorrect information. So
Okay, thank you,
definitely with
ma'am.
the proper review and reprompting, we can improvise that and make it correct.
Thank you, ma'am.
Sure.
Hi, ma'am. Thank you for this more detailed level presentation and explain the thing. So I was like, you were talking about this predictive and preventive maintenance using this AI and ML. We can do it better way. So that time, like, are you talking about any of the ERP applications which is being used in manufacturing industry, or independently also few models, AI or ML models, we can use to do all kind of this kind of preventive or predictive maintenance?
Yes, yes. So
So
this is applicable in all kinds of industries. Predictive means uh, we are feeding the model to a series of data set, and it will learn the past trends from that data set, and it will come up with the predictions with the real time data. So once we feed the data, we train the model with lot of historical data sets, right? It will derive the patterns, the cues, the insights from the data. Then after learning this, we have to test it thoroughly, whether like by giving it to some sample data set and some test data, we can observe its output, like whether it is able to predict, let's say, anomaly prediction, right? Anomalies in different monitoring systems. We are monitoring the performance of a infrastructure, right? Virtual machines or cloud infrastructure. So there, um, uh, how the model will predict that there might be some breaches or certain mishaps is by taking the cues from the historical data. Like it will see these are the data set which comes under normal behavior, right? And if anything which goes beyond a certain limit or certain range of the normal behavior should be termed as anomaly, right? So this there are various models available already in the market, like RIMA model, which can predict the near future, right? And predict the anomalies also, the future values also. Normal, even if it is a normal value, it can predict accurately that after 2 hours, this metrics value for this system will be this. Okay, so it can predict up to 80-90% accuracy. So yes, I mean, to answer your question, it is not only applicable to ERP or manufacturing. So predictive models can be applicable, can be applied to any sphere of industry.
Okay, ma'am. Thank you. So one more question, like, is it really affordable for low scale industries to go for this, like any kind of, as you said, there are few models already available. So is it like only like, high scale industries which are having good revenue or something they can only use, or it is also for low scale industry, manufacturing industry, they can also go for this kind of, AI or ML models with low cost?
Yeah, not really. So there are varied ranges of manufacturers, right? I mean, I am not very sure what you are pointing to, like at low scale, but see, like there has to be certain investment always, right? So these some of the models are freely available, but the investment in which we have to do is by hiring the developers to and data analysts to adopt the model, to implement the model in our industry specific, in our organization specific arenas, right? So in those terms, the investment has to be done. It is not like we just get the model and put it on the ground. So it has to be fit into the scenario, and the right data set has to be given to train it. The right automation, the use cases has to be identified, then only it can deliver the results. So yeah, small scale industries are also adopting it. It's not like only large scale industries are adopting this, but
Yeah.
they should look at the ROI factor, right? The return on investment. So if they find it useful, or they think that with this kind of investment I can derive this kind of results which will help me, which will benefit me and give me the profit, right? Then definitely they can take a call to adopt.
Okay, ma'am. Thank you so much for this detail level explanation. Yeah, thank you.
Sure.
And there is another question in the chat box. What strategies are necessary in machine learning operation for manufacturing to monitor and retrain models that experience model drift due to changes in production?
What strategy means? I think the question itself talks about the answers also. So first we need to identify the model. We need to fit it to the right scenario, right? Unless until we fit it to the right scenario, right use case, it will not be fruitful. Then give it a huge set of training data, historical data. Then the model can, yes, the models are again, the models are meant for different scenarios. For different scenarios, different kinds of models are applicable. Not all the models can deliver value for all the scenarios, right? So there we have to take the right decision. We need to take help from the SMEs in this area who can guide us to adopt the right kind of model. Then we have to train it with the right set of data and do good amount of testing. Then we can put it on the field, on the ground, to observe what kind of output it is delivering. And as I already mentioned about the strategies, right? Measure, monitor and iterate. So we have to continuously monitor it, keep on improving by the learning loop, and also like from the cues from our testing, the results we get from our testing data, right? And then keep on improving, then only it will finally deliver the results. It's not an easy task, but definitely it can make it possible.
There is another question in the context of Industry 5.0, how machine learning based automation enables human machine collaboration rather than replacement.
Yeah, so I think I touched upon one point there, which talks about the cobots, right? So cobots are immensely helpful, where where is it? So where it can collaborate with the human beings, it can take the orders, like a set of directions from the human beings, and it can deliver the exact set of actions. So that is where though it is, I mean, it is very risky to completely depend on a robot, right? Still it is evolving, and we cannot completely rely on a robot, but with a little bit of human intervention, definitely we can gain a huge benefit out of these cobots. Does that answer, or I didn't touch upon any point?
Yes, ma'am. Yes, ma'am. If any other questions from the participants, you can unmute yourself. Uh, if there are no more questions, we'd like to thank Madam for the very insightful this talk on the use of AI and machine learning in automation. So thank you, ma'am, for accepting our request and delivering this talk. Thank you.
Thank you so much for having me.
Thank you, ma'am.
Thanks, Ipsa. Bye.
So we will wait for 10 more minutes for the next session to start.
If I can drop off then?
Yes, ma'am. Yes, ma'am.
Sure. Thank you.
Thank you, ma'am. So we will wait for 10 minutes. At 7:30, we will start our next session. Good evening, sir. Oh, hi.
Hello, good evening, all.
Uh, Good evening, sir. Good evening, all participants. So, we have our next speaker, uh, Mr. Jagdishwara Rao Surisetti. So, he has done his master's from Indian Institute of Technology, Bombay, and is presently working in CBMM. It's an Niobium metal producing company, and he is responsible for Asia technical development of niobium based microalloy for steel with applications in structural, yellow goods, and API steel grades. So, previously he was with the hot rolling mill production head and process metallurgist with 17 years of experience in managing challenging assignments with eminent organization in India and Southeast Asia. As production head, he led the plate and stacker mill with a capacity of 1.2 million ton per annum, development of lean chemistry steel grades. He has exhibited a strong and firm approach to sustain and encourage continuous improvement principles to increase process efficiency and business unit cost control. Uh, Hot rolling process design, lean manufacturing, product development, continuous improvement, best practices in process cross-functional collaboration analysis. Sir, welcome you, sir, to this ATAL DP online faculty development program on Industry 4.0, that is transforming manufacturing through advanced technologies. Sir, you can start your talk now. Thank you.
Thank you very much, sir. My screen is visible now?
Yes,
Yes.
visible. Yes, visible. You can
Okay,
put in full screen mode. Thank
yeah, I put it in a full screen mode
you.
actually.
Yeah, okay.
To begin with, thank you very much to a respected IGIT team, especially Professor Amulya Malik sir and as well as Professor Ipsa madam, to giving this great opportunity for me to provide the insights of about the niobium metallurgy as well as in the how the some technology programs our company is working since almost last 5 years. So as about me, as sir already mentioned, and today, as many of you maybe don't know about CBMM, so I just want to introduce about what is CBMM. CBMM is a Brazilian company. So it's a Portuguese word. The full form is a Companhia Brasilia de Metalúrgica e Mineração, means a Brazilian metallurgical and mining company. What this company does is this company only talk about the niobium. It was a very old company founded in a 1955, and it is completely operated from the Brazil, and they have the ore. Basically, we all know about that niobium as a metal element with a periodic arrangement of 41 number, and it is producing from the pyrochlore ore, which is Nb245. The concentration of the niobium in this particular ore is at 2.5%. So CBM is the only company in the world who produces the niobium. 90% of the world market shares going to the CBMM. So how CBMM works, develop these all these products. It's almost having the 261 projects in which 176 partnerships with the customers, university, 60 universities and research institutes, as well as the continuous research towards the 25 universities. So the my responsibility is more towards the structural steels. So the structural steels, everyone knows about the structural flat, rebars, as well as beams and the sections. These applications will be used in the many parts of the world, from the wind towers to a shipbuilding, pressure vessels, industrial machinery, metal structures, and reinforced concrete structures. So this is by seeing all these things, basically you understand that the application of niobium in the steel as a microalloy. To understand the this niobium metallurgy with respect to this steel, as this has been almost since last 70 years, this research is being going on to develop the niobium applications throughout the in a different applications, like not only in the steel. Nowadays niobium applications is also going towards the uh, particularly batteries and the space applications. But at present today I would like to focus more on the steel industry. If you see here, CBMM has developed some metallurgical software tools which helps the steel manufacturing units, particularly from the steel making point of view and continuous casting point of view and reheating furnace, as well as in the hot rolling applications. First I will start with these simulation tools, then how these simulation tools will be try to connect in the AI. So that is my objective, because these tools are individual tools generated based on the applications. One for the like steel making area, one for the like thin slab casting area, another for the micro sim means hot rolling area, another for the phase transformation, as well as the continuous annealing simulations. So how these tools we are planning to connect to AI models, that I would like to explain. But before going to that explanation, I just want to go through a brief introduction about the each tool, how the tool operates, what is the functions of this tool and all. So TCO. So what is the TCO? TCO is basically a total cost of the operation, as well as we are also thinking about in the steel industry towards the decarburization. So keeping in the mind before when we are developing this tool, we keep in the mind of the steel industry. How can we niobium can help to decarbonize the steel industry, which also helps in the total cost of operation plus the alloy design optimization. So as we already know that niobium is a microalloy, and this has been using in the steel industry since a long time, particularly for the grain refinement as well as the toughness properties and some corrosion resistance properties. So niobium to the manganese ratio with respect to the property, which is defined around 1:30. So that is a part of alloy design optimization. That metallurgy also we know about that how to get this alloy design optimization. But how this ultra niobium concept will help in the decarburization of the steel industry, particularly some part. I am not saying that full part, but some part of the steel industry. I just give a small example. We are using a steel plant many ferroalloys. So when we are using a ferroalloys, example, if you are
Excuse me, sir. We are in the starting slide only.
sorry, it's not running.
No, sir.
Oh,
Yeah. Now
okay.
it yes, sir.
Because for me it is showing actually. That's why
Okay.
I'm going on.
Okay. Now it came, sir. You can continue.
Okay, see now I'm just in the second slide. Is it okay now?
Yes.
It's
It's in
running now or
10th
not? It's running now.
slide.
Yeah. Okay.
10th slide.
Otherwise, I will stop and again start. Okay. Now this is 10th slide. Okay. Good. I think my internet has a small less connection. Now is in 10th slide. Yes, I am talking about the decarburization slide. Okay, so when we are talking about the ferroalloys in the world are producing with a different processes in which example here the graph showing about the to produce a 1 ton of a ferroalloy, how much amount of the carbon monoxide per ton is tons we are producing. So this is the uh, data we collected from the different technical publications. And if you see the ferroniobium consumption production for 1 ton of ferroalloy, it is using 1.66, whereas other ferroalloys is going around 33.66. And earlier, the ferroniobium concentration is ferroniobium production around 5 years before is also taking around 5.5 tons of carbon dioxide per ton. But by doing some process changes in the niobium production, it was come down to a 1.66 to make it more competitive with for the steel industry. So some ultra low niobium concepts with respect to the TCO benefits. So whereas I mentioned that TCO will benefits in the alloy design optimization, enhanced performance with a low manganese strategy, and further TCO can be calculated by using the some process parameters optimization. So this is one tool. This tool can be performed online as well as to the based on the customer requirements. Now I just go to the next tool, which is a concast sim. So concast sim is a another tool simulator which can be used in a product design before when we are designing a steel chemistry with respect to some particular continuous casting machine. Uh, we always think that okay, some casters nowadays coming with a very advanced features, but even though after running the casters with so many years, we are facing an issues of the slab cracks. We called it as a transversive crack, longitudinal cracks in the industry. So to give a idea about the process engineer or a process metallurgist, this tool will help. How this tool will developed? It is developed based on the real industrial cases and the equations, as well as the process parameters and the different chemical compositions. By giving a very small inputs to this tool, it will give a approximately 80 metallurgical process parameters outputs to the engineer to take the decision that okay, is there any still option to reduce the alloy composition or the process parameters. So this tool will give very simple concept operating based on the like traffic signal system, which is a green. It give you a indication of green means yes, this process parameters are very good, you can go ahead for the casting. And yellow is a alert, and where you need to do attention. Why? Because adjustment of some process parameters or the alloy design chemistry according to that particular caster is required. And red is a showing a high defect risk. So this type of tool can be used, this simulator can be used for the slabs, billets, as well as the beam blanks. And we are using this tool to the many of the our customers to help them, particularly if when they are facing some cracks issues. And almost with the like I can say, like in India we are using with this particular type of tool with the sail. I can, and in Brazil we are using this tool with the Gerdau steel. So those results are coming and giving more insights and how this tool will work. Example, this is a online tool. Then the tool name is called Concast Sim. If you see the screen here, it is always asking the, give me a minute. Example, if it is for some particular client, who is the client name and the country, those what are the slabs, beams or beam blanks type of the caster, and what is the present concern. It is the present concern is about the transversive cracks or a longitudinal cracks or some other problems we can mention here. Then after this we can make the simulation inputs. The inputs requires the full chemical composition of the steel, the real chemical composition of the steel with respect to the each element, as well as the particular continuous casting machine. Example, when we are working with a slab caster that has the critical parameters of like what is the metallurgical length of the casting machine, what is the mold length of the that machine, slab dimensions like thickness, width, what is the variables process, we call process variables, which are minimum casting speed how much, maximum casting speed how much. These are the real casting machine information, we need to give an input here, as well as the type of oscillation, which is a stroke based or a oscillation based. Once we give this information to this tool, this will give us the output. As I mentioned earlier, it is around 80 outputs it will provide, out of which some outputs I put here, which is like according to the some particular chemical composition, the manganese sulfur ratio should be a greater than 135, but it is coming 500 means it will show in the green. If it is coming say less than 135, just in the 130 something like that, it will show in the yellow color. That means then we go back to our alloy chemistry and check the what is the manganese levels and the sulfur levels. Can it be reduced a little amount or not? Same like copper content, corrosion index, carbon equivalent. As we all know about the if the carbon equivalent is less, means thermal stresses will be less in the steel. So these some of the features I mentioned here, like aluminum nitrogen component, calcium to the aluminum nitrogen, transversive crack tends, and transversive crack tends towards the minimum casting speed, mean casting speed, maximum. Many features are there here, and the report will be customized and it will be generated in the PDF format. So this is another type of tool which we are using continuously for the customers. Then coming next to the microsim tool. So microsim means basically it's a microstructural evaluation tool. What this tool will do and for whom this tool will be help basically. This tool was formulated, this is not a very new tool. This tool was formulated almost 7-8 years before in collaboration with the CBMM as well as another university in the Spain, which is called CEIT. Why this tool was developed? We all know that when we are rolling, we are always having a heterogeneity in the microstructure. So the
Sir, again it's constant.
Oh, sorry. Please let me know because from my side it is scrolling.
Okay.
Now it's scrolling down. Give me a minute.
Continue.
Is it okay now?
No.
I am not okay. Okay, just give me a minute. I start from beginning again. Is it changing now?
No.
Hello.
Yes, sir.
I am sharing the screen again. Please give me a minute. I think. Is it running now, ma'am?
No. Now we cannot see the slide presentation. You can share it.
Yeah, I just shared now. I closed the sharing and again I'm sharing now.
Yes, yes.
Give me a minute. I'm sharing again. Ma'am, are you able to see the screen now? Hello?
Sorry, presentation screen.
Yes. I'm talking about
Oh,
presentation
no.
screen.
No.
Not yet? Okay.
No.
is not giving the option. Give me a minute. I don't know. Can I reconnect again? I think I have some issue with the internet. Give me a minute.
Yes, sir.
Ma'am, is it okay now? Can you see, please?
Yes, sir.
Okay. I'm going back to the slides. Okay, we are in a micro sim, a powerful tool. The same screen you are seeing now.
Same screen.
Okay, thank you. I think I have some issue with internet connection. I just reconnect again. Thank you for being. So basically, as just before we talked about the total cost to the operation as well as the Concast sim, which is using more towards the secondary steel making and the continuous casting operations. Now we are moving to the hot rolling operations, where this sim, the sim present which I am showing about the micro sim. So basically, micro sim is a how it will works, why it was developed. When we used to work with the rolling mills, we always have a doubt, particularly at the during hot condition at the roughing stage and the roughing stage as well as the finishing stage, what kind of pre-austenitic grain size is generating. uh, Before example, if you talk about like 10 years, we know about the fundamentals of the hot rolling, but the percentage of how much real recrystallization is going on, we used to always going to the lab and depending on the label. But this particular tool which developed particularly for the uh, industries as well as the metallurgists and the product design engineers. So when we make any alloy design with respect to some particular mill, at each particular stand, roughing stage as well as the finishing stage to the finishing last stage, what is the austenitic grain, without going for the real rolling, it can be give a some idea. Okay, how it will give some idea, I just go through that. So that is the reason why this tool was developed, and where this tool can be applied. Basically, as I mentioned that this is a microstructural simulation tool. These tools will be applied for basically different types of the hot strip mills, like in hot strip mills and the plate mills, particularly for the flat products, which we call direct strip processes, hot strip mills, plate mill, stackle mills. This is comes under the flat product category. Whereas when we are talking about the long product category, this comes under the rebar as well as the H beams, which are the we called it as a light section mills and the medium merchant mills. What is the model output? Okay, model, before talking about the output, the model inputs are very easy. The model inputs are alloy design. What is the actual chemical composition of the design alloy we are talking about? Then the hot rolling process parameters. When we given as an input to this model, this will give the output of the niobium solubility and the niobium in the solution by rolling pass. That means, example, say in a hot strip mills, normally sometimes we have a one roughing stand or two roughing stands. In a finishing in a same hot strip mill, finishing stands having 6 and 7. So at each stage of the rolling pass, it will provide us the how much amount of the niobium in the solution. Then recrystallized and non-recrystallized fractions are the pass, and niobium carbonitrate precipitation at the each stage of the rolling, and average and the maximum austenitic grain size values, and mean flow stress, accumulated strain, and it also have the other features like niobium scan, through thickness analysis. Basically, when we use through thickness analysis, particularly for the when we are rolling for the thick sections. Thick sections means when we are talking about a plates, we roll say 50 millimeter or a 25 millimeter. We need to understand about what is the surface austenitic grain size, center austenitic grain size, as well as the quarter austenitic. This information can also be provided by using this tool, as well as the phase transformation tool. So as I just mentioned that this tool also helps to increase the rolling by optimizing, not only giving the outputs with respect to the metallurgical factors. Apart from that, it also give an advantage to the process and the product engineer. What is the rolling productivity? How can we enhance the rolling productivity by using these particular process parameters, reheating and the process temperatures? Sometimes what happen when we design an alloy, uh, we don't know that what is the right reheating furnace temperature. So this will give an idea by using the how much amount of the niobium in the solubility, at what temperature the this complete niobium in the solution, at 1100 degrees centigrade or 1150 or at 1200, based on the composition of the alloy elements addition, and grain size distribution, and through thickness homogeneity. So one of the example I am just showing here, when we invented this microsim, we run to the many types of the steel plants. And this example, if you see the left hand side, the S420 is a type of the steel. It's a niobium free steel. And SM S420 is a niobium microalloyed steel. We try to optimize the rolling process parameters as well as the chemical composition and the mechanical
Sir, it's
properties.
not moving.
Okay. Process and products, yes. We are at process and products, correct? Ma'am,
Sir, we are in the starting slide only. It's not moving.
we are in microsim slide, correct, ma'am?
No. Now it came to microsim slide.
Yeah, okay. It changed now or not? Not yet,
Now
yes.
we are in 23 number slide.
23 number. Yeah, now it is moving. Okay. This slide, yes.
23.
Yeah, model. Uh, now changed or not? Process and products.
No.
No.
We are in models and outputs.
Yeah, that's the thing I am looking.
And now came to process and products.
Yeah, when I am going back to from the presentation mode to the normal mode, it is changing actually. When I am going to a presentation mode, it is not changing.
So you can
I will
show in
continue like
normal
this.
mode. Yes.
Yeah,
Yes,
I'll
sir.
continue like this. Okay,
Yes.
okay, no problem. Basically, I just explain as the slide is not moving. I am just going back here, and basically this model can apply for the different types of the mills and the outputs. As I mentioned here about the advantage of this model is particularly for the optimize the yield and the tensile strength, elongation, toughness, weldability, and fatigue and flatness properties, and also to reduce the carbon equivalent. So I am just giving some insights on the how once we run this model in the live, some outputs I put here. Example, if you see in the screen, sorry that I don't know why it is not in the presentable mode. Ma'am, can you see my MFS through thickness analysis screen? Ma'am? Hello? 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 Hello?
Yes, sir.
Yeah, I'm just trying to reconnect again because I tried again, it was disconnecting. My voice is, I think, not audible.
And now it's 30%.
Okay, okay. So I'm just showing here the outputs of the micro sim, some outputs, not all. Basically, if you see the screen, this here it is showing about the mean flow stress analysis as well as
Yes, sir,
the
please share the screen.
actually sharing option is not coming, madam. Give me a minute. Yeah, okay. Can it be seen now?
Yes, sir.
Okay. So the some outputs of the a microsim I mentioned here, which is the mean flow stress relation with respect to the each pass from the roughing mill stage number 1 to the roughing mill number 6, as well as the different finishing stages. So it will try to compare with the mechanical flow stresses as well as the metallurgical flow stress. The blue lines indicates the mechanical flow stress, and the yellow dots indicates the metallurgical flow stress. And it also gives the information about the critical grain size and the recrystallization fraction at the each pass, as well as the what is the mean grain size of the each pass at the each pass, as well as the fraction. If you see the next screen, here we are talking about the example when we start a rolling at the roughing mill stage after from the reheating furnace. What is the average grain size? Example, if you see here in the screen, the average grain size is coming between 70 to 300. When it finished the rolling at the last stage, it is showing around 0 to 20. That means how the grain size was evaluation done from the roughing mill's first pass to the finishing mill last pass, we can get in the live condition as well as the before practicing of the rolling. If you give the inputs to the model, it will give some idea. The crystallization fraction example, say if you see in the roughing mill 1 to the roughing mill 6, it is showing the 100% recrystallization going. In the screen also it is showing about the uh, in the graph here is showing the complete recrystallization. When it comes to the temperature is coming down, how much amount of recrystallization going, and percentage of the non-recrystallized area, and percentage of the solute drag effect. Along with that, the stain accumulation in the material is also showing. Is my screen changing now, ma'am? No? And the phase prediction model with the okay, this is the additional model recently developed, particularly once the rolling is completed, uh, based on the cooling rate. It is a simple continuous cooling transformation model, but it is with a real chemical composition, and the it will take the input of the pre-austenitic grain after the last rolling stand. Either it is a finishing mill or at the another type of the mill, and based on that, it will give the fractions of the ferrite, perlite, bainite, and the martensite, and it is also validated with the some real steel manufacturers. So so far whatever I explained, I am explaining is completely about the different types of these tools developed in a different platforms. But now what is the objective we are doing? Because when we are talking about a process from the steel melting, casting, and the hot rolling is a one particular big process. How can by doing all these four tools, can we make try to make this in a AI or not? So how it can be combined with the AI? So after, as these all the tools are working very nicely with the real life, we are going into a next level, which is the artificial intelligence. We are in a talking with the another company, as the we know that the so far the tools which I discussed just before, TCO concept, concast sim, and micro sim to micro sim, and the heat soaking sim, as well as the phase transformation sim, they're working independently very good. But how can we bring all these tools to the one platform where we are using completely AI as a key platform? Because example, if you see here, uh, give me a minute. So when we develop the particular tool, the tool comes under the industry 3. Industry 3 means, example, as you mentioned, that by using some other types of platforms, those tools were developed. Microsim tool, concast sim tool, and they're working individually good. But for a process engineer to get the full idea at a one sheet, how can we make it? So to become that idea very well, we started using the artificial intelligence for particularly combining this all tools in a one as a big platform. So how this is we are developing is, we are trying to connect with this particular tool with the help of the artificial intelligence, then the machine learning and the deep learning. We hired a company particularly regarding this. So by using all these tools, it will define the problem and collect the data from these tools, and data pre-processing and the cleaning. After that, it will try to run the choose the model and train the model, evaluate and tune the model, and deploy and monitor. This type of tool we are trying to develop by using these four tools. Why this can be a very good? Because as of now, what I explained is only about the physics-based models, which are like microstructural simulation model is completely a metallurgical model, which uses the metallurgical fundamentals. Concast sim is a model, metallurgical fundamentals for plus some practical experiences. So some tools are there, but still it is not fully realistic. To make it more realistic, we would like to combine these tools physical models as well as the data models to make it a hybrid modeling. So how this hybrid modeling will start thinking about? It will take the raw hello, hello ma'am. Is my screen changing now? So this hybrid modeling is particularly talking about the taking the raw process data, which is having the chemistries, past schedules, cooling strategies, mechanical test results. From there, we are already, I just explained before that we are explain a microsim model. When the microsimulation model is using for the hybrid model, we call it as a DLL model, which is a microstructural evolution, because as it is having the smart features of the mean austenitic grain size, recrystallized fraction, grain size distribution, phase fractions, and the ferrite grain size. So for the raw process data, one Python based machine learning model will be developed, which is which learns the final process specific correlations. By using these two methods of the microsim, combining the microsim and the Python ML model, try to build a high accuracy prediction model, which we called it as a hybrid microsim AI model, which will give us the mechanical properties, which are yield strength, tensile strength, and elongation, based on the physical model as well as the machine learning model. So how this architecture look likes, the core features. Example, at the left hand side we have the microsim DLL tool. At the right hand side we have the Python ML stack. So the metallurgical feature generation and the simulate this output as a key function for the Python ML stack. So we will get the data from the microsim input, then also from the level 2 mill data, level 2 production data, sending this to the Python ML stack, and it will give the results to us. So the results will be a real-time prediction results, which considering the mechanical properties and process set points and the real-time quality alerts. So to make it this model, as I mentioned, that the key important is that the physics of the engine is the microsim model, which is the unpacking the metallurgical brain, which is we called it as a microsim core. And module 2 is a phase transformation model, because these two models will club together, will provide us the most of the data from the rolling mills, which gives us the austenitic grain size, recrystallization fraction, strain accumulation, austenite grain size distribution, as well as the final phase fractions, final ferrite grain size actions, and the dislocation density. By doing this, we go to the module 3, which is the key outputs of the model, which we called it as a mechanical property prediction model, yield strength, tensile strength, and the other along with that different strengthening mechanisms. Different strengthening mechanisms means the key strengthening mechanisms for the mechanical yield strength as well as tensile strength are like solid solution strengthening, precipitation strengthening, uh, um, grain size strengthening, etc. So this is the final architecture of the model, how it will look like. Integration of the production data and the metallurgical mechanical mechanisms with the AI tool by getting the hard rolling data. By getting the hard rolling process data into the AI machine learning tool, as well as microsim tool data, microsim simulation data, particularly for the phase transformation sim, as well as the microstructural evaluation sim data going to the machine learning, and it will give the online quality prediction, optimized alloy design and the reduction costs, achieve higher value added alloys, and accelerated product development. So basically, how these models, what are the resources we are using to develop these models are particularly the real steel mills, hot rolling mills, as well as as a research partner, we are using the CEIT as a research partner for this. So the expertise will be the all metallurgical background knowledge and the hot rolling mill knowledge covering into the putting into this model to make the uh, complete hybrid model. Hello. Hello, ma'am. Hello. Hello. Hello, ma'am. Hello, ma'am.
Yes, sir.
Actually, I just finished the presentation. Okay, so the presentation which I shared is I added many slides with respect to the new advances, basically. So those slides also I will share later.
Okay,
So
sir.
if you have any questions on that, then I can explain.
Participants, if you have any questions, you can unmute yourself.
Thank you, sir, for the wonderful lecture. Sir, I have a question. As you have discussed the role of niobium in the steel industry and
Hello.
Good evening, sir, and thank you for
Yeah,
the
please.
wonderful.
I can hear you. Please.
Okay,
Yes.
sir. So as you discussed the role of niobium and updation with the AI in steel industry, is your company doing anything in this regard related to high entropy alloys? Because the refractory high entropy alloys, which is a high temperature alloys, have many wide use of niobium as a alloying element.
You are
So,
100% correct. I just want to share you a new screen. Give me a minute. Basically,
sure, sir.
because today I talk only about the steel. What we are working also, I just want to share you. Give me a minute, please. Okay. Are you able to see my screen now?
Yes, sir.
Okay. Now, if you see the seconds, what we are producing ferroniobium, niobium oxide, and niobium metal, and
No,
vacuum
sir,
grade
the
alloys.
presentation we are unable to see.
Yes, sir.
Oh, yeah.
Slide is not visible right now.
Okay. Give me a minute. It's the problem today I'm facing really. Okay. Is it okay now? Are you able to see any screen?
Yes, sir.
Yes, sir.
Okay. See, your question is well taken. Thank you very much for that. As you mentioned that for the refractories and alloys, so we are always working towards the innovation. Our objective is to increase the application of the niobium. Yes. So to do that, if you see the product, it's earlier 10 years before we used to produce only a ferroniobium. Now this company is considering the new applications. We are producing now niobium oxides, niobium metal, and vacuum grade. How this will be required? I just give you a small explanation. Give me a minute. Yeah. Can you see this slide? The slide is showing about the programs ongoing.
Yes. Yes.
This is a very interesting slide I can talk about. If you see, we call this as a niobium curve. Like we also call this as when we are studying a steel, we talk it as a banana curve. Yes, banana diagram. Do you remember? So the
Yes, sir.
banana
Yes, sir.
diagram, banana diagram normally talk about the from the mild steel. Now we are
Yes.
talking about the AH, advanced high strength steels, and DP complex steels. We are going towards about 1800 megapascal. Like this, we also our company also make a aluminum niobium curve. A long back, when you are seeing here pipe, a auto stainless steel was showing in the maintenance. As maintenance means this is already developed. We just would need to maintain only. When it comes to the complete left, there is a two idea and there is a research phase. So if you talk about the research phase, now a niobium completely research is going towards the batteries, glass products, fuel cells, electronics, and idea and the titanium alloys. So as I mentioned earlier, we are in a research activities actively with the some global leaders. Example, I just give me, you see. Our company is investing on the research every year, $60 million US dollars per year. With whom? With the customers, the real customers who are interested to work with the niobium, and the 41 universities as well as the 15 research institutes in the world. So this is a completely working towards not only about the steel, it is about the products which are showing in the this curve, particularly titanium alloys, electronics, fuel cells, glass, and the batteries particularly is going on, and some research still going towards the cast iron and the cast aluminum. As you mentioned that refractories single entropy, that is not put here, but I heard from some of our scientists in the Brazil, they are talking about that, the refractories concept you mentioned.
Okay, sir.
Thank you, Naveen.
Questions from participants? Any other questions?
Actually, from my side also a little apology because I don't know, my network is not good today or what. I try to run the presentation mode. It is unable to share, but then I go back come time 2 times, 3 times. Basically, see what I would like to tell that I used to work also as a, normal process engineer, but now after doing all these activities, I am seeing that there is a lot of scope for the metallurgical engineers and the process engineers how to develop the tools. First example, if you see the CBMM, they develop a different tools of like total cost to operation, alloy design optimization, decarbonization, concast sim for the slab casting, billet casting, microstructural simulation tool for the hot rolling, particularly for the flat as well as the long products. Now, as we understand that steel plants are talking about the industry 4, so how can we help? Because we do work or not work, neobeam will sell, but our company will not work like just go and sell the neobeam. It's not like that. The objective is to how we can create a value to the customer by supporting in a as a partner, not only to the customer, as he mentioned, Navin mentioned about the person, some research is going on with respect to the neobium, some developments needed. 100% CBMM will help on that. Now our objective is to develop this by using all these tools, make a hybrid model for the different mills in the world. So example, the case I presented today, the hybrid model, which is under process and already working with a Brazilian company, Gerdau, as well as the CSN company. Now this year, first time we are going to, because the micro simulation tool in the India is already using by the ArcelorMittal and the JSW Tata Steel since last 3 years. So we are working with them, particularly JSW or probably MNS. First, they come up with, they are ready to share the data. We are trying to work with them to develop the hybrid model for their hot rolling mill as well as the plate mill. Yeah, that is the conclusion.
Okay, sir. I have another question which is not technical. So your company is involved in a lot of things from metal alloys to AI related things. So what are the career opportunities for a research scholar or a MTech graduate in your company? If you could say something regarding this.
Okay, it's a good question. Basically, see if there is a there is a very good potential project was there, then you can straight away contact us through a madam. Then we can see the case, because normally every time we call it as a NTS projects. Apart from the regular projects, we called it as a NTS, means development projects with the research institutes as well as the research students. If that project really thinking that in a good way and make futuristic, then company is ready to invest in that. Of course, we need to go to a very strong what we called it as a patent type thing with the Brazil, because it's a Brazilian company, and but they're more technology oriented, so they're ready to take the challenges and as well as the new upcomers.
Thank you, sir.
Ma'am, I hope uh, my presentation is okay. Ma'am, I cannot hear your voice actually.
Sorry, sir, it was in mute mode. So it was very nice presentation, and you have also discussed the simulation tools, tissue calculator, concast sim, head sim, then phase transformation simulation, micro simulation. So you have given the detailed idea of where we are using these things by giving reference to your Navium based producing company, your CVMM. So it was very beautiful presentation.
Actually, ma'am, these tools can be operate live also. Example, I don't have a time, but example, if it's a open end tool. If you open the link in the direct internet, it will open and it will give you the information in a fraction of 1 or 2 minutes. Every tool will give you the what is the TCO, what is the according to the chemical composition and the process parameters. Yes, ma'am.
Yes, sir. Thank you, sir. Thank you, sir. Any more questions from participants? Someone asked, Jyoti Sankar Pati asked, could you please share the link for that tool?
Yeah, yes, I will share.
Okay, sir.
I will share to you, ma'am. Then you can share to them. No problem. If they
Yes,
are
yes.
unable to open, then they can discuss with me anytime. No issue.
Yes, sir. Yes, sir.
Thank you, ma'am.
Any more questions? Okay, so then we can conclude the session. Thank you, sir, for keeping our invitation and this SART movement and coming to join our online FDP.
Thank you, ma'am. Thank you very much for this great opportunity for me and all of you also. Good night.
Thank you very much, sir. Good night, sir. Good night. So for participants, tomorrow we have our last day of FDP. So we will start at Amelia, it's 2 p.m. in afternoon. We'll start at 2 p.m. So we'll join in afternoon at 2 p.m. We will have 3 sessions tomorrow, and finally we will have the exam related to whatever the things we taught in these 6 days. Then we will conclude. Okay. Thank you all.